Hello, I'm Mark, and welcome to my channel. Today I'm going to be doing a tutorial on how to use my Seren Vehicle Movement Plugin to move this spiffy looking Jeep, as seen here, across the desert floor. And since this is going to be using my Physics Movement plugin, we will be doing all of this in blueprints, so no C++ is going to be required for this tutorial. Hooray! And also, if anyone's interested and want to use my plugin, I will be leaving links to the beta version of this, which is being distributed through my Patreon site right now. I'm currently just using Patreon while I'm continuing to kind of develop out my plugins, but I think eventually the plan is to eventually get this up on Fab as well. For anyone who wants to kind of use this physics system that I've been kind of creating and building out. And if anyone's interested in the asset pack that I'm using, this asset pack was created by Digital Drive Studios, I should say. So I'll leave links to the pack on Fab, so you can go and check it out there. But if you have your own vehicle that you kind of want to use my plugin on, as I'm kind of building this out, I kind of show you all the things you are going to want to take into consideration when setting up your asset, so that you can get the best results from the plugin. All right, so as always, we do have a lot of ground to cover in this tutorial, so let's get started. All right, so let's get started with a little bit of housekeeping first. So first off, I'm going to be using, under games, I'm going to be using blank as far as the Unreal Engine project. We don't need any of this other stuff. So I'm going to use a blank project, blueprints only. You can either use maximum or scalable. It's up to you. And then just give it a name. I've called mine Seren Vehicle Live. And then just hit create, and that should go ahead and create the project for us. So once we have the project, I'm just going to move that off. I included the cars pack. So this is what I'm going to be using. Again, link will be left in the description below. But I really like this Jeep. It's set up to go into Unreal Engine without any additional work. So I really appreciate that from the guys over at Digital Drive Studio. So all those folks, good job. So that should get you started, ramped up pretty quick. So we'll just move that off there. And then also I went ahead and brought in some level prototyping, but I don't think we're going to be needing that. Originally I was going to use the Vigilant vehicles like I had in the previous series, but as of December they've decided to move on and go in a different direction. So that's kind of what forced me to go look for the Drivable Cars series through Digital Drive Studio. But again, the guys at Vision, great vehicles, but yeah, I understand, they're going off into something new and hopefully very lucrative for them. So good luck with them. And let's see, so that sets everything up there. So the only other thing we need to do is get the plugins in. So to do plugins, so if you're going to use my plugin, you can go ahead, download it from my Patreon site. And once you get it, you should get it in a zip format. So once you uncompress it, you'll get a folder structure. And so what you're going to want to do, there's two places which you can add plugins. Well, three places technically, but there's only really two main. And I'm going to be doing a video series on creating plugins since that has the greatest demand on my site right now through the poll. But a quick little, I'll go into this in more detail when I do that. But the two places to add it are, you could either add it globally to the engine. So you can come into, so I've got mine, here's Unreal Engine 5.7, engine, plugins. And the best place to put it is actually in this folder called Marketplace. If you've just got a brand new installation and you haven't downloaded any plugins off the Marketplace, you probably won't see this folder. So if you don't see Marketplace, just type in Marketplace just as you see it right here, and then you can go ahead and drop the Seren Physics Movement plugin right there. Just take once you uncompress it, just take the whole folder and just drop it right in, and you should be good to go. If you don't want to do it globally, but you just want to put it into the project, then it's just going into your Unreal projects, find the project that you've got. So here's my Seren Movement. Again, if you don't have any plugins in there, you might need to go ahead and create this folder. This folder only really gets created at the project level if you're actually going to go ahead and create your own plugins. But if you want to keep plugins local, you can just go ahead and do it here too. Go to plugins, and then from plugins, just take everything, just take that whole folder and just like you did with Marketplace, just drop it right in. And I would advise you could, and once you do that, I would probably say make sure that that your editor is closed and then just reopen it, because what it's going to do is it's probably going to force you to want to restart your editor anyway. But once you do that, you should be able to come in and you can go to plugins, and it's under gameplay movement under installed, and I set this plugin so it can be self-installed. So if you open the project back up again, it should come back in an installed form, and then that's what you see. And I'm using Seren. This version of this video is going to be done in version 1.1. So there's a 1.0 and a 1.1. I'm using 1.1 because I made some little modifications to the wheel thrust and cornering stiffness and how I calculate that. And that looks to be a lot better. Especially when using real world data, which we will be using for this Jeep. All right, so once you got that, everything's installed, we should be good to go. So I'm just going to go close that. And let's get started. I think the best place to get started here is with the asset pack. All right, so let's come back up to our 3D cars. So if you've imported the 3D cars asset pack, this is what you should get. You've got blueprints, which we don't need. Maps, we don't need. Materials, we're not going to do anything with materials. Meshes and textures. These are we are just going to be exclusively working in the meshes. As you can see, you've got actually two vehicles here. You've got a hatchback and you've got a 4x4 and a 4x4 advanced. I'm going to be using the advanced since I think most people are going to be wanting to, when creating physics vehicles, they're going to want to have vehicles with deformations, and this pack actually is set up also so that you can do that. I'm not going to go into that. I'm only going to be focusing on setting up the vehicle so that it can take advantage of the plugin. But if you want to then start playing around with what else they've got, you should have all the pieces there. So I'm going to go and click into advanced. Under advanced, you've got physics assets, skeletal meshes, static meshes, and then you've got the default skeleton, right? So let's see if we open up the default skeleton. It's just the default skeleton of this, so we don't need that. All right, so what we need is the physics asset. That's what I really wanted to come into. So as you can see here, this is a physics asset that we're going to be using. And this is for the advanced vehicle. And so with the advanced vehicle, they just created all of the collisions around the major parts of the vehicle. And this is actually a pretty good physics setup for the collisions on the vehicle, especially when we're using physics. So what I'm going to do, because we need to make one small little change here so that we can use it with a movement system. So to do that, I'm going to go ahead and just duplicate this. And instead of 5, I'm going to go 4 and call it sim. And the reason why I'm going to do this is because the only little change we need to do this so that it can be used with our stuff is go into physics type over here and come down and convert that to simulated. Once this is now set to simulated, gravity and everything else will do its thing on this mesh or on this physics asset. So that's the first thing, and then I'm going to then come back to the skeletal meshes. So you have two folders. This is the folder LOD0 is high poly, LOD1 is low poly. So pick which one you want. I'm going to go with the high poly for this one. And we're going to come down to in asset details, we just need to make one little change. And I'm just going to change it right on here. And instead of using this, we're going to use the PA physics 4x4 sim, which is the one which we changed. Hit save, and now everything should be lined up. So now we can go ahead and start building out this vehicle in our blueprint. So I'm just going to go ahead and close that real quick, and let's go back up to the content drawer. Under blueprints, I'm going to create a new folder. I'm going to call this vehicles. And under vehicles, I'm going to create another new folder called 4x4 Jeep. All right, and in here, let's go ahead and create a blueprint. So I'm just going to use a regular old pawn blueprint. So there it is. And let's just call it 4x4 Jeep. And we can open this up. So here is our system, or here's our pawn, right? And what we're going to do is let's go ahead and set up the vehicle with all of the static meshes and the cameras and stuff, so we can get that going first. Okay, so first off, we're going to need a skeletal mesh. So I'm going to type skeletal. There's our skeletal mesh. And because this is physics movement, we want to make sure that we put our skeletal mesh as the default scene component. And then from here, we're going to go to skeletal mesh assets, and let's go find our vehicle. I'm using SK 4x4 LOD 0. And that should pull in right there. So if that's the one which we're using, that's under advanced, and that's the one which has been set up to use the simulated physics asset. So I'm just going to save that. So there's our vehicle. And before I move on, let's go ahead and set this to simulate physics. So we're just going to come down to physics here. As you can see here, simulate physics, set that to true. And as far as the collisions, I'm just going to set this to vehicle, since it's a vehicle, so that's how that's going to work. And everything else for this video is just going to be set to the same. We're not going to change anything here, so I'm just going to go minimize that. We will be coming back to this because we will need to set up the an animation engine for this, but we'll come back to that when we are ready to once we've got the wheel system set up. But for now, we'll just leave that off. Gonna hit compile and save. So now we've got that set up. So now let's go ahead and set up all of the other parts of the vehicle. So we can do that rather simply by just coming into the content. I'm just going to come back up to our skeletal meshes for our vehicle, LOD 0. Right, and so what we have is we've got the bumper, hood, doors, and trunk. So all I'm going to do is just going to go grab that, drop that under the skeletal. So there's our bumper, and it automatically does that. We can then do that for the hood. There are bone points if you want to attach it. If you do that, you're probably going to then want to go ahead and move this into correctly into position. But for now, just go ahead. I'm just dropping them in. Door left. Go drop that in and make sure that that skeletal mesh is attached to that guy, so it's in the right position. Door right. For some reason, it's putting it in the wrong place. And the trunk. Oh. Attach. I suppose I just need to select that. All right, so there we are. So there it is with all the parts of the vehicle that I'm going to be bringing in as far as the skeletal pieces. Next, let's go ahead and dress this up a little bit more. So to do that, let's go ahead and bring in the extras. So as you can see here, there's a lot of extras here. Actually, no, I don't want the extras. I want the static meshes, right? Yep. So I'm actually going to bring in these pieces. I'm going to bring in the, let's see, what looks like a good tire. So, well, let's bring in the wheel first. So I'm just going to drop that there. And this one I can actually attach to the steering wheel. So that's going to put that right there for me. When it comes to some of these other attachments, what you may want to do is go into the actual mesh and add sockets. It'll make your life a little bit easier, but I'm just going to go ahead and just attach them as is, since I don't want to touch the raw asset right now. So we've got the steering wheel. Let's go ahead and get the other pieces in. So what else have we got? We've got the black fabric wheel. So as you can see there, it's a little bit off kilter. So let's go ahead and adjust that real quick. So I'm going to go ahead and put, I think I was using for, let me put this data in. So I'm going to adjust the location. And the, I guess the rotation. Let's see. Yeah, it doesn't look like it's right. Oh, that's because it's on the steering wheel. Why did you do that there? Steering wheel, let's just set this back. So I'm just going to do that off. Alright. Black fabric. Let's go ahead and adjust this. Alright, so there's our black fabric spare tire on the back of the Jeep. Gotta watch for that. Make sure you click on skeletal mesh before you drop anything on, otherwise it'll try and attach it. Even though you're saying attach it there, it'll actually attach it somewhere else. Let's see, we've got the left and right mirror as well as the central mirror. Let's bring in the central mirror next first. So I'm going to go grab this, just drop that in there. And we need to position this, so I found that I think 215 as far as the height, so that kind of pulled that in there, and I set this to 25. So the red is 25, blue, so that's the X. And then the Z is going to be set to 215. I found that's a good place for that. And let's see, we've also got the left and right wing mirrors. So let's go ahead and, whoops, before I do that, this is going to put this in the wrong place again. Attach. And let's go get the other one as well while we're here. Alright, so for right wing mirror, I am going to put a Z of 40. And I'm going to do that of 10. This is going to be -2. And as you can see, it's not lining up, and that's because I'm just going to go ahead and add it to the right door. Well, 10, 40. Let's see, right door. Oh, it's rear right door. This way. There it is. Alright, so that kind of lines it up there for me. So we'll do the same thing for the left. Actually, I'm just going to go ahead and just put it into the socket first. And then we'll adjust its location. So and this will be -10. So let's see, what's that look like? I want to make sure there's no gap there. There we go. Alright, so got the mirrors on, and we've got the back tire in, and we've got the steering wheel attached, so it looks a little bit more like a Jeep. So now we are going to go ahead and set up the wheels. So for the wheels, I am electing to go with, I'm going to go with this wheel here. So I'm just going to go ahead, before we do that, let's click on skeletal mesh since we want to put them up there. So I'm just going to go ahead and drag that up. So there it is, and I'm going to rename this. And I'm going to rename this, this is going to be my front left. So this is the front left wheel. This is going to be my front left wheel. So all I'm going to do is I'm going to come here and attach this to front left. And as you can see right now, it looks kind of funky. And that's because we just need to rotate the wheel. So I'm going to say 180. Nope. Rotate the wheel. 180. So I'm just going to rotate that wheel, and then that pops it right into the place where we want that wheel to be. Alright, so I'm going to compile, save, and then I'm going to right click and I'm going to say duplicate, and this is going to be front right. And we're going to take this and put this on the front right, and because that's kind of set up the and then we're just going to go ahead, since we duplicated it, we just need to take the rotation out, and it will rotate it in right into the right place. And then I'm then going to take the front right wheel, and I'm just going to go ahead and duplicate that, and going to call this rear right wheel, and we're going to go ahead and put this onto the rear right wheel socket right there. And I'm just going to go ahead and select the left wheel again, and I'm just going to duplicate that. And we're just going to, again, just attach it to the socket. All right, so that's the wheels. So because we're using a physics simulation, what we're going to want to do is everything under here, because we're going to then come down and we are going to reset the collision presets. So I'm just going to go ahead and set this to no collision, and the reason why is because if you're not careful, this could, if any of these start hitting the physics asset, since this is a physics system, they will start creating forces on the vehicle. So to take care of that, we just want to set those to no collision, and that should be okay, because one, the physics asset is actually going to take into account all these parts, and if it isn't, you can always update by adding a little cube around where the mirrors are and everything. And as far as the wheels, my physics movement component will take care of the collision between the wheels and the ground once we've got that set up. Alright, so that sets up all of our vehicles. So again, everything which is attached to the skeletal, just make that no collision, and that should take care of it. So let's go ahead and put some cameras in here. So first off, I'm going to go ahead and let's add a camera. So I'm just going to go grab this camera. I'm going to rename this first person camera, and let's put this in the first person location. So this is the camera when I'm inside the Jeep. So to do that, let's just scroll up, and that's going to be the X location. That's going to be the Z location, and we need to put it kind of where the driver's head's going to be. So that's roughly where the driver's head's going to be. So that's our camera perspective when we're driving inside the vehicle. So I'm going to hit compile and save, and then I'm going to do a third person. So to do that, we're going to add a spring arm, and on that spring arm I'm going to go ahead and add another camera. And I'm just going to call it TPP for third person camera. Let's make that capital C. Alright, and so that's attached to the spring arm, so we need to do some spring arm settings here. So first off, I am going to give this spring arm. So there's no real attachment point. Again, if you could put a socket in there if you really wanted to. I'm just going to go ahead and just put a location for the spring arm. So I'm just going to go ahead and say location is 120. So it's going to be a little bit high right now. But then I'm going to go ahead and put a socket offset of 120. Actually, just going to move this actually. Let's see, where do we want this? Going to move that maybe over the maybe put that in there just a tad. Alright, so that can be there. So I'm just going to move that there, keep that there. That's where the third person camera is. And I'm just going to go ahead and do the arm length to 600. So that should give us plenty of room to see the vehicle. And I've just set that there on the vehicle. So that's a different location. Then compile and hit save. Checking the angle real quick. I think that looks good. We can tune it later. All right, so that should be setting up the asset on the vehicle. So we've got the vehicle, we've added all the pieces, we've set the collisions so that everything should be happy. So let's go ahead and bring in start setting up the components so that we can then start working out all the physics stuff that we want to add in. Okay, so to add the component, all we're going to do is we're just going to come up to add. So we've got the plugin in, so we just need to find it. And so again, all my components are using Seren. It's just a cool name that I like. So there's a Seren vehicle movement component. This is the component that has everything that is going to act as the broker between inputs, and it's going to then map it, allow the input mappings to the simulation So this is where all the magic is going to happen, right within this component. So we can just add it straight in as the Seren vehicle movement system, and it's coming off the physics system. So that's all good to go. And then, so now that we've got that in there, we're ready to start putting in some data, some real world data, so start building out our vehicle. So let's go over to the physics system and see what we've got. So right now I'm just going to get rid of anything that we don't need. So I'm just going to minimize that so these distractions can be out the way. So we need physics movement. This is the base. This is my base component, and then the vehicle is built on the movement component. We don't need component tick because that is already preset. We don't need sockets. We don't need that. So here we have simulation input settings under physics vehicle movement, and then we have under physics movement we've got the mass settings here. So I'm going to start off with mass so we can kind of set this up and then move on and go back and move back into the vehicle. So for mass, I'm going to go ahead and set the dry mass of the vehicle to 1,905 kilograms. So that is the dry mass of a Jeep Rubicon. So again, I went out, looked up the mass for a Jeep Wrangler, and I decided to settle on the Jeep Rubicon. I think this Jeep Sport is a little bit lighter, but I decided to go with the Rubicon because I wanted a little bit more mass on there. And then I'm also going to turn on center of mass. And the reason why I'm turning on the center of mass is because right now the component, the only little issue I have with the skeletal setup of this, again, it's set up more for actor movement, and so the root component is, or the center, all the root bones actually go into a root component which is on the ground, and because we're using physics, if you're using physics, you don't want necessarily the root to be on the ground. You kind of want to have it in the middle of the vehicle because that's the torque point where you really want it. So because of that, I'm just going to go ahead and change the center of mass so we can kind of make it feel like it's rocking left and right a little bit when we start going into the turns. So to do that, I can elevate the center of mass. So I'm going to go to 60. And since this is a Jeep, and I'm going to move the center of mass a little bit further forward over the front engine. So I'm going to move that forward as well. So here, this is where we can do mass manipulation. So this is actually going to, so when the simulation starts, it will actually move our center of mass for us right at the very beginning, so that we have a vehicle which is going to feel like it's got some a center of mass a little bit above, so it'll rock a little bit, and it'll also feel a little bit more nose heavy off the physics particle. So gonna save that, and I think that's everything we need there. So we should be done with mass properties. We'll keep that open. Let's come up to simulation, and I'm going to start off with environment. So this is our linear dampening solution. So let's go ahead and set this up. So I'm going to set this up for a medium 1. So medium 1 is the plugin's air. solution. And let's go ahead and set a profile up and set this for air. So again, with this plugin, you can have multiple profiles for different mediums. So if you wanted to have vehicles that react differently when they go from the ground or from the air into the water, you can then suddenly change that, push that linear dampening right on the fly. It is supported within the plugin. And again, all things which change simulation, that is all. I've also set that up for network replication if you want to run that over the network as well. But we're just going to do a simple standalone here for now in this video. So forward axis and side axis, we don't need the up-down since this vehicle is going to spend most of its life on the ground. So I'm only cared about movement in 2 directions, not 3 directions. All right, so to set this up, let's go ahead and let's see, where are we? So again, I got the dimensions for a Jeep Wrangler, so I'm just pulling those in. So this is the front. So we've got the height of the Jeep, which is 185 centimeters, and the width of the Jeep going into the wind is 187 centimeters. So it's a little bit wider than it is taller, which is a good thing, which makes it more stable. And then let's take a look at the side profile. So this is going to be on the y-axis. So this Jeep Wrangler's length is roughly 422 centimeters. So again, this is all in centimeters. So if you're going out there and you find something using imperial, you'll just have to make the conversion from base 12 to base 10. But that's all that information. And as being a former Jeep Wrangler owner myself, these things, when you're driving at high speed, feel like they're driving a brick into the wind. So I'm going to put a rather stiff drag coefficient on there. So, and there's no lift. Yeah, I'm not going to put any lift. You could put, if you wanted to do, if it was kind of like a race car and you wanted it so that as it gets, if it's using a lifting body, or I should say a downforce on the body, you just make the lift coefficient negative and it will push down instead of pull up. So all right, so that should set up that. We're only just going to use one medium for this, so that looks good there. And so that should do it for the fluid system. So next I'm going to move all the way down to the axles, because I want to set up the axle system first. So this is the big departure from the original system that I wrote and demonstrated in the video series. So the axle system, this just came about from kind of reading through some of their code and looking at other things and just thinking about how would I solve these problems and what actually made better sense to me. So, and I think, it's like, we should start with axles and then move from axles then to wheels, and how do we want to set that up that way. So this is kind of how I'm setting it up, and it's kind of a relational system. So the axle system is here, so we need 2 axles. So it's a 2-axle vehicle. So there we are, and the front axle is going to be steering enabled. I'm just going to keep the roll bar scaling as is for now. And this is going to be the front axle, and this is going to be the rear axle. So if this is an axle which has no power, so if it's a vehicle with no, like a trailer, right, you just use a free axle, and it's just going to roll with the vehicle. It's not going to provide any power. But if you wanted to have a distinction between vehicles with power, or you just wanted to have a distinction between this is a front axle and this is a rear axle, you can use the front axle and rear axle settings. So this is front, this is rear, and this will now give us power options when we get to the transmission system. All right, so I'm just going to hit Control, compile, and save. So this is where we get to our first blueprint. So this is the steering system. So in the old system, it was a struct, and it was defined Here, I wanted to make it so that you could have different options on how you wanted steering to work on vehicles. So this is just a more classic vehicle, so I'm just going to have steering enabled in the front. If you wanted a vehicle with steering in both front and back, you could also do that by just enabling it in the back as well, and then you'd create one blueprint for the front steering and one blueprint for the back steering. But for now, we're just going to go with a simple, boring front steering. So now that we've got this turned on, we need to go create our first blueprint. So for our first system. So let's come back up to blueprints. We're going to go into vehicle. Actually, no, we're going to come into Jeep. And here, I'm going to go ahead and create a new folder called systems. So this is going to be a folder that's going to carry all of the systems for our Jeep. And under here, I'm going to go create another folder called Axle. And under Axles, again, I'm going to create another folder called Front. And I'll create a separate folder called Rear. And we'll get to that once we've done the front system. So under front axle, I'm going to come under here and go to blueprint class, and we don't need common. Instead, we're going to come to all classes, and I'm going to type Seren. And under here, the component has in the component we've got a lot of blueprints that you can use. So this is where so we have the physics engine, we've got steering, suspension, and then under physics systems, we've got for aircraft, you've got control surfaces, fluid braking. So this would be for things like deployable spoilers, deploy air brakes, things like that, or split rudders. Physics foils, these are our wings. It can be used for aircraft wings or submarine dive planes. Sponsons, this is if you want to float something or allow it to float and submerge. So, and then you've got thrusters, and then under here you've got gimbal, static. So again, everything I broke everything out into classes in this version. I just felt that it was just a lot easier to work with. And then we've got the physics transmission as well as physics wheel. So we'll be working with a subset of this for the vehicle. So the first thing we're going to look at as physics steering. So let's go ahead and select that. Let's give it a name. All right, so there it is, and we're just going to open this up. So when you open it up for the first time, there are no event. There's nothing in the event. This is just purely data. So all of the code for this object is actually handled by C++. So there's nothing to override here. We just have to set the data. So here you've got some settings. You've got single axle or single angle. This is usually good if you're working with motorcycles or tricycles on landing gear of aircraft where you've got the nose gear, right? That's probably just going to be a single wheel, or it could be a double wheel on a single pivot point. So that's where you'd probably want to use single. For cars, angle rotation method is probably the one you're going to use. This is going to be, but I also have anti-angle as well. So if this is just like a normal vehicle, and that's what we're going to do here, you can set it up to angle. Angle is going to kind of mimic the Ackermann rotation, where anti-angle is kind of like an anti-Ackermann. So if you want a more stable, if you want more stability in the turn, then you're going to using the angle rotation method is the best way. Race cars tend to use the anti-angle rotation or the anti-Ackermann because they want more predictable steering, but it's also less stable. So I've got both in there, and it'll recalculate depending on what you're trying to get. I'm just going to go with angle rotation. I'm just going to keep it at 0.7, but again, depending on how many axles you want steering, you can kind of customize each one of these blueprints to kind of get a better steering angle on each one. And I'm going to go with 35 for the steering angle. So Jeep Wranglers steering is usually off the shelf. Stock is usually between 30 and 40. Depending on the vehicle, so I'm going to go a happy medium and going 35. If this was a back axle, you may want to flip this to is reverse. So if this was steering on the rear axle, not the front axle, just flip that switch. Otherwise, if it's on the front, I'm just going to keep it like that. I'm not using any speed versus steering angle curves, so we don't need to worry about that. We're just going to keep it simple. So we save that. We can come back to our Jeep now. And when we do this, we should see there it is, BP 4x4 Jeep steering. This is just showing you the class that you could use that's associated. We're going to use the BP. Again, because it's a plugin, if you are doing C++, you can always derive my classes, and I think I've got enough. I've been putting a lot of virtual classes in there, so if you needed to override something, you could go ahead and do that. But again, if you're just blueprints, you can just use it as is. All right, so now we've got steering set up. Let's go ahead and look at our wheel and suspension. So this is the wheel suspension system. And so each wheel is going to have its own independent suspension, wheel and suspension. And I did this because in case you wanted to kind of tweak parameters between the left side of the car and the right side of the car, as well as the front and the back. So, but we're just going to go with the stock. So here again, we have the Seren Physics suspension, and we also have Seren Physics wheel. So let's go ahead and set up the suspension and the wheel blueprints next. So let me just compile and save. All right, so under my front, I'm just going to go ahead and right click, and we're going to go to blueprints. Under all classes, I'm going to say Seren, and we should see suspension. There's physics suspension, so I'm just going to go ahead and grab that. And I'm going to put suspension FR for front, so there's a distinction between front suspension and rear suspension. If you wanted, you could just create one set of wheels for both suspension and for both front and back, left and right. I'm just going to do front and back. I'm going to put different ones for front and back. That way, if you wanted to tweak the front suspension and the rear suspension of the vehicle, you could do that. Again, lots of ways to configure this so you can get, create the vehicle that you really wanted. So under here, under suspension, I'm just going to open this up real quick. Let me go back to my other vehicle. So as you can see here, again, all data. You don't need any event graph here. This is just all data settings. So hard stop stiffness, just keep that as is. I'm going to put a max rise and drop of 10. I'm just going to keep the defaults for the ride height. The spring rate, I'm going to bring this up to 300. And I'm going to set that to 200. As far as the damping ratio, I'm just going to keep it at 0.5. As far as wheel load ratio, let's just keep this as 1. Raycast margins, we don't need to do anything there. Suspension smoothing, I'm going to set this to a 5. So this can go anywhere between. So this will help to smooth out your suspension. And this is pure. This is more for the suspension animation. So if you really want a really smooth suspension, you can take it up to 10. Otherwise, I think 5 is good enough for most suspensions. And then because I'm going to be using suspension a lot. If this was an aeroplane and I just wanted landing gear, I'd probably just use simple, but I'm going to use complex sweep. And then we're going to keep everything in raycast. It's rare to use spherecast. It's there if you need it, but for the most part, I'm just going to use raycast. I've been finding raycast is perfectly acceptable for everything that I need right now. So I'm just going to go ahead and compile that. And so again, you can play around with the suspension settings. So spring rate, this is how springy you want it. So if you're working with a vehicle and you find that the vehicle is sinking into the springs, then you might want to increase the spring rate to kind of push the vehicle back up so it's on its suspension. So this is kind of how springy the suspension is going to be. And then the preloading is, again, just another value to work within the spring rate. Max rise and drop. This is the how far up and down off center your suspension is going to be moving. Damping ratio, again, how it's going to damp out the suspension. So if you find that the vehicle is kind of really bouncing around a little too much, you may want to increase it. Or if you feel that the suspension looks a little too stiff, you can bring the damping ratio down a bit more. So I'm just going to keep it at a happy medium of 0.5 and start there. And wheel load ratio, again, it's just how much, if you've got multiple wheels on the left side and right side of a single axle, you may want to take the wheel load ratio and bring this down to distribute that load a bit more. Otherwise, if it's just 2 wheels, you can just set that to 1 on it for each side. All right, so that's there. Hit compile, hit save. So that should do it for suspension. So now let's go ahead and do the wheel. So I'm going to come to Blueprint class, type in Seren again. I'm going to scroll down, and then there's the physics wheel. And then I'm just going to put an FR so I know that these are the front wheels and not the rear wheels. And let's just open it up, and I'm just going to save it. All right, so under wheels, again, if you come in, wheel physics, wheel configuration, right? So I am going to set up the values for this. Let me go over to my other one real quick, see what those values are. All right, so I'm going to hold off on the wheel mass, radius, and width until we get the vehicle to a point where we can actually put it on the ground and see what's happening. Because this is going to be how you're going to figure out what that wheel radius is. Actually, I'm going to set the width to 22 because I roughly know what the tire is going to be and that's the width of the tire of the Jeep Wrangler. And I know what the mass is going to be for the tire size, so I'm just going to put that in for now. It's going to be 45 kilograms, but I'm going to hold off on the wheel radius because I'll show you how you can use some of the things you're going to need to take a look at when you're going to determine what the actual radius is. And it's important, and I'm starting off with wheels because knowing what the wheel radius is going to determine what differential, final drive differential gear we're going to need. And I'll show you how you can get that information. All right, so that's that. As far as brakes are concerned, I found that 10,000 is good, and I'm also going to make these handbrake enabled as well on the front wheels. I'm going to keep ABS. If you want anti-lock brakes and traction control, you can turn them on or turn them on or turn them off. It's up to you. Right now I've got these systems tied to the wheels. Maybe in a later version I may move this up to the axle, but for now it's actually based on the wheel. External torque, we're going to keep that as none. I'm going to go to additive for wheel friction, surface area multiplier, and I'm going to go to 0.3. So the way that I calculate friction is it's a 2-part variable. The first one part is actually coming from the physics material that you're driving over. So if you're working in materials, you can actually create a physics asset for that material, and the system automatically does a line, when it does its line trace, is actually looking for that physics material. Now, if you're not using it, it will come back with a default number of 0.7 for friction. But if you wanted to then say, over gravel, you've got like 2.0 versus ice would be like 0.0 or 0.001 friction, right? You can set those in the materials or the material assets for that. And then as I'm kind of doing the ray trace, I'm picking that up. And so that's the first part of that coefficient that we're creating for the tire friction. The second part is going to be the wheel surface friction. And the reason why I'm breaking this into 2 parts is because when you're calculating wheel surface friction, it's usually that tire on that material. But in a video game, right, we can't change the physics assets on the fly for a specific tire and get all that information from the physics asset. So instead, I decided to say, look, the physics asset is going to be that's a constant, and then the value in the tire is the constant, and then we just combine them. And then we can either combine them using an additive process or a multiplicative process. It's up to you on how you want to then do that. Axle efficiency. This is how much. So wheels are not frictionless on an axle. No matter how much grease you put on an axle, it will eventually spin down. So this is the efficiency of the axle. So this is the efficiency lost when an axle is turning. Cornering stiffness. So in the old one, I had to have pretty high numbers. In the new one, I've got pretty low numbers. And that's because I'm actually calculating the cornering stiffness a little bit differently. And again, that'll come back into play when we start looking at wheel radius and the wheel width. So, so with the wheel width, so when I'm looking at longitudinal forces off a tire, I'm actually multiplying that by the wheel width, and that will actually get me the much better value of force that the tire is driving the car in the forward direction. Where cornering stiffness, what I'm doing is I'm actually taking the radius of the tire, dividing it by 3, and then that is and then that gets multiplied by the cornering stiffness here. So that will determine how stiff on the left and the right of the car it needs to be able to corner. So these numbers can be a lot lower, and the reason why it's about how much of that tire is, because it's the tires and what's in contact with the road. The whole tire isn't in contact. Only a third, roughly a third of it, is in contact for left and right, where the whole width, or maybe really the tread of that width of the tire, depending on what type of tire you've got, is really in contact with the road. And so that's the multiplicative forces that are going to be needed if you want to use real world data in your physics simulation. So that's the change. That's why it's now Seren 1.1. Works much nicer in getting your cars to drive off the grid. All right, slip threshold and skid. I'm just going to set this up to 100 for now. And we don't need any offsets on here for this particular mesh, so we're good. So that is our tire and all the profiles that I'm going to be using. I'm not going to use any lateral slip graphs for this, so we'll just keep it just using standard cornering stiffness. All right, so now that we got that set up, we can come back to our Jeep and we can go ahead and set this up. So suspension and wheels and wheels. So that's all we really need to do there. So then the only other thing was we just need a location. So if we go into our skeletal mesh, so I'm just going to close that, and let's go to our advanced skeletal mesh. So if I open up this guy, and so this is the skeletal mesh that our vehicle is using. So here we can actually go ahead and find the wheels. So here's the front right wheel, here's the front left wheel. That's the caliper. We don't want the caliper. We just need the bones. So what we're looking for is we're looking for the bone name, because that's going to be the rotation point. So all you can do is just go copy bone name, come back to the Jeep. So the first one, I usually go with the first one as being the left side and the second one as the right side. So let's just go get those two bone names. Copy bone name. And then I'm going to put a little bit of an offset, because this bone is actually going to stop at the disc rotor and not in the middle of the tire. So to get it into the middle of the tire, Going left side, I'm going to add a -20, and on the right side, I'm just going to put in a +20. All right, so that should set up the front axle. So we've got our suspension, our wheels, suspension, wheel, the bone names are set up, and we've got some offset. So let's go ahead and do the rear. And get this set up. So this is actually going to be pretty simple for now. All I'm going to do is I'm just going to go back into my blueprints, vehicles, Jeep, systems, axles, front, and I'm just going to do is I'm just going to go grab these. I'm just going to go ahead and duplicate them, and I'm just going to go ahead and move those into my rear folder. And just to make things a little bit easier, whoops, no, I don't want to duplicate that. Let's just delete it. And all I'm going to do is I'm just going to rename this. So where's my rename? I'm just going to go RR for rear and rename this. So that's rear. So once we got the rear in, I can now come back to our Jeep. And right now, I'm just going to keep them as the same values as the front. But if you want to then go ahead and make things a little bit more spicy by changing the front and the rear, you can go ahead and do so. So again, rear suspension, rear wheel, rear suspension, rear wheel. Gonna copy that. I'm going to go to location, and let's go ahead and get that bone information. So rear left wheel, I'm just going to go copy bone name, come back, bone socket, just going to put that in there. That's for the left, copy for the right, and again I'm going to go -20. And 20. All right, so that is the setup. So I'm going to be using, so we're going to then also go in there and we want the, I want to turn physics suspension on. So there it is. And that's under settings. So if you come under here, go to settings, suspension, use physics, turn this on, and this will use the chaos suspension interface. And so again, that will automatically then set up everything for the wheels. And we don't need to do anything here. This is mostly if you're going to be using the arcade style transmission for idle brake inputs and stuff. We're just going to keep this as defaults. And as far as the wheel tracing is concerned right now, as you can see, everything looks okay. We're just going to ignore the vehicles. That's already set up. So tracing will ignore anything which is set to vehicle, and it will hit anything else. So I think we're good there. All right, so now that we've got all this done, and we've got all the vehicles, wheels set up, before we can go ahead and just drop this in and start to see how the wheels look, we need to go ahead and create an animation engine for our skeletal mesh. So let's go ahead and do that. And so, and this is going to be used to help drive the wheels, spin the wheels, and rotate the wheels on the road. So to do that, to create an animation engine, I'm just going to come in. I'm going to go ahead and just put the animation engine here for now. So to do that, I'm just going to come up and say blueprint, animation blueprints. Going to find the vehicle that we want. I think it's this one's car-based skeleton. All right, so I think it's this one for the Jeep. Let's just double check that actually. Skeletal mesh, load. Yep, it's this one. So they're just reusing the same skeletal. So just gonna go back. So it's using this car-based skeletal mesh there. So we're just gonna go ahead and use that. So let's go back to our animation engine real quick so we can do some setup there. All right, so let's go back to our Jeep. So we need to set up the animation engine for our Jeep. So to do that, I'm just going to come up here. So right now, this is using the default animation instance. We don't want to use that. So to change this blueprint to use what we want is the Seren animation engine, so that it can, because that engine is actually hooked into the Seren movement component and will pull out any animation bone change data for us, so that we can then just go ahead and map it to the components we want it to change. So to do that, if you've got the animation instance here, it's just go to File, go to Reparent Blueprints, and then just type Seren, and then there's the Seren vehicle animation instance. And now it's reparented to that, and once it's reparented there, we're ready to go ahead and create the animations that we need. So first off, I'm going to get the mesh space ref pose. So we're going to need this. And off here, we're going to need to do a bone transform. And we want the bone transform modify. And what we're going to be modifying is the translation, which is going to be for the suspension, and the rotation, which is going to be for spinning and turning the wheels. And to do that, we just need a function called the get vehicle bone transform under the category animation, and this is all we need. So I'm going to split that, and we just need to make sure that we map the right bones. So this is actually going to interface with a repository that's constantly getting updated from the physics thread of the output information. So the animation engine the output is giving us all the data. This will then go in and grab the latest and greatest, and then set that up into a nice little array or a map for us. And this is just a handy dandy function so that we can grab this information rather easily. So this is the left wheel. So here we're going to go ahead and set this up for the left bone. So to do that, we just need to make sure bone modify. So front wheel left. So that's under skeletal control, front left wheel, make sure these two are the same. And then for translation, we're going to go to add exist and keep it in the component space. And then for rotation, add exist and then keep it in the component space. And then all we have to do is just set that to there and set that to there, and we've set up our left wheel, or our left front wheel. So to do the other wheel, I'm just going to go ahead and just copy this. And so this is going to be the front right wheel. So I've got that. I'm just going to come into the bone space, set this to front right wheel. And I'm just going to make sure that this is front right wheel. So left wheel to left wheel, right wheel to right wheel. Again, make sure nothing's changed, add to existing. So that all looks good. And then I'm just going to copy these two. And hook that to there and put some reroute nodes in. And this is going to be to our back tires. So this is going to be rear, where's our rear? Rear left wheel. So rear left wheel, rear left wheel. And this is going to be our rear right wheel. And this is going to be rear right wheel. And then finally, we just need to hook the pose up, and this should add a component, component to local back. All right, so that's the animation engine set up. It's using the same one for the hatchback. If you wanted to do a hatchback, you could also do that as well. All the assets are there. So that sets everything up. So the same skeletal name. So as it's animating, it's going to go pull this information, pull the output product information, and put it into let the animation system use it for us. All right, so that's set up. So let's come back to our Jeep, go up to the skeletal mesh, and find our animation blueprint. There it is. APB 4x4 Jeep. Hit compile, hit save. And we can close that. We can close this. You want to set this up before you go ahead and put this on the ground. Otherwise, if you don't do that, then your physics, the wheel system is going to look like a bunch of wet noodles. And we actually want the vehicle to actually look like it's standing on the ground. So let's go ahead and do, so for next, let's go ahead and do the test. So we're going to go ahead and drag this vehicle onto the map, and it should be standing on its own suspension, kind of. So I'm just going to go ahead and move this off screen, and we'll bring up a map. So I actually have a map made called Grim Lake, so I'm just going to go ahead and do that. So it's just a big open desert, so that we can go ahead. We've got lots of room to drive a car around, and we can also take it up into the hills as well and test out the suspension there. All right, so let's go ahead and bring this vehicle into the map. All right, so let's go ahead and get our vehicle. So I'm going to come up to the Jeep, grab it. I'm just going to put it in the desert. I'm just going to lift it up a little bit so it bounces. Well, sometimes it does something weird like that. Just going to go ahead and delete that and try it again. All right, that looks good. So, and it's not flickering around, so let's just keep it like that. I don't need it that high off the ground. Let's just say, I think that's good. It'll give some bounce. All right, so let's go ahead and run this and see what happens. Oh, before we do that, we should go to details, and we're going to set this with the vehicle selected. We're going to set to player 0, so we're going to auto possess it when we hit the play button. So let's go do that. Hit that, and we're in camera 1, and as you can see, we're kind of inside the vehicle. So we're not really seeing much on the outside. So let's go ahead and set up our first-person, third-person camera setup so we can actually see what's going on the outside of the vehicle as it's kind of bouncing around or rolling around on the ground. So I'm just going to stop that, and we'll come out of our vehicle. Just move this around a little bit. So, but yeah, we want to get a camera angle like that so that we can kind of see our vehicle and see what the tires are looking like. So to do that, let's go ahead and go into the content drawer. Let's open up our blueprints and let's start setting up some cameras. So we're going to be on event begin play here, and I want the spring arm. Actually, I want the spring arm for this. So on the spring arm, I'm going to say set relative position. Set relative rotation, I should say. And I'm going to shift the rotation from 0 to 90, which will give us a side profile shot of the vehicle. And also, I'm going to go ahead and grab the cameras as well. So that we're going to start our camera in the third-person view. So I'm going to set that to active, and we'll set... And we'll unset, make sure that the first person camera is unset. Alright, so I'm going to hit compile and save. So active, not active, and we're going to rotate the spring arm. And then I'm going to add a couple of debug buttons for this vehicle so that since I don't have any inputs created yet, we're just going to use the debug buttons. So I'm going to use debug key 5 to for the spring arm, and while I'm here, I'll do debug key 1 for the cameras. And since everything's in blueprints, we'll use a flip-flop. So this is a handy little macro if you need to switch between two states. So I'm just going to hook both of them in there. So this one, we're going to be switching the relative spring arm between two states. So since we're going to be starting off at 90 degrees, when I hit it the first time, this is where I'm going to set it back behind the vehicle again. So that's going to go to 0. And if I hit it again, it will then set me back to side angle, which is our 90 degrees. So, and you know, while I'm here, I'm actually going to add a little bit of camera lag into the system. So I'm actually going to turn camera lag on for lag and rotation. As far as rotation, I'm going to go ahead and keep the I'm going to keep the lag speed to 10 because I don't want the vehicle to get too far away from the camera. So the higher the value, the less technically the faster the camera will catch up with the vehicle as it's tearing away. But for rotation, I'm going to go to 5. So as the vehicle starts to turn, we should start to see the vehicle kind of turn, so we're not going to be always right behind it. All right, so turn lag on while we're here setting up the cameras. And then for right now for debug key 1, I'm just going to go ahead, grab these, and let's go ahead and hook this up. So again, when I hit this key, I want to change the states, so I'm just going to first hook them up. All right, so since we're starting off with in third person camera, when I hit this key, I'm going to turn third off and turn first on, and if I hit it again, we'll go back to the original on begin play state. All right, So that should set everything up. So when we run the vehicle, we should see the side profile of the vehicle and see what's happening with the tires. So let's go ahead and move this off screen. And we're back to our vehicle, so let's go ahead and run this. And as you can see, the camera moved in, and as you can see, our vehicle, yeah, it's kind of sitting a little bit low into the ground. So we want to go and change this. So what we're going to do is we're going to go into both the front tires and the back tires, and we're going to go and reposition those. And again, this, if you're working with this may take a little trial and error, as you kind of, in order to kind of get the tires to be where you want it to be. But once you got the value of that tire, then you can use that number. And we'll use that because we're going to need that number when we go to the transmission, so make sure that we get the correct gear ratios, the gears and gear ratios set up to drive this vehicle. But yep, so yeah, it's a little weird, so let's go ahead and fix that. So to do that, let's first stop the simulation. And then let's go into our content drawer, go back to systems, axles. I'm going to open up the front wheel. And while we're here, I'm also going to open up the rear wheel too. So I'm going to go ahead and just put a number in because I kind of worked this all out for the other one. And that magic number is going to be 48 centimeters. So those tires are about 48 centimeters. I'm going to use 48, probably more like 49, but for me 48 works, and I'll show you why. So I'm going to hit hit compile and save, so that these blueprints are all set and good to go. Move it off screen again, and let's run it. And as you can see here, the wheels are now sitting up, and as you can see here, if you look at at the bottom of the tires, it looks like they're kind of depressed into the ground a little bit. And again, that's just an effect. So that, remember, the tires have no collision, and it's the suspension system that is taking in the tire's size and setting up the collision box or the collision spheres around the tires to map that. So I wanted it a little bit smaller than the maximum tire, so it looks like it's actually, the tires are a little softer when it's in contact with the ground. So the ground's a little soft, the tires will, so it kind of looks a little bit more like a tire on the ground versus a hard wheel. So that's the value I'm using. So it looks like our tires are set up now. The suspension's looking good. So now I think we're ready to move into the mechanical setup of the vehicle. So let's go ahead and do that. Okay, so to add an engine, it's just as simple as adding another blueprint. So as you can see here, we've set up our wheels. Everything looks good. Our suspension is working. Our fluid dynamics profile, we'll see that in action when we start moving the vehicle. But we need an engine and a transmission in order for us to move this vehicle. So to do that, we're going to come under mechanical systems, and then under mechanical systems, we've got enabled. So click on this, and it will open up our ability to get to engine and transmission. And as you can see, just like wheels, and axles and steering, it's another class. So we just need to go ahead and create those classes. So let's come back to the content drawer, and we're going to come up to systems. So under Jeep systems, go ahead and create a folder called mechanical if you don't have one already. So under mechanical, I'm just going to go ahead and create a blueprint class, Seren, and there's the Seren Physics engine. Underscore, so I'm going to give it a name, BP. (4x4) Jeep. All right, so we can now open this up. Actually, I'm just going to go ahead and open it and close it and reopen it again. First time it'll open up with the event graph because it assumes you're going to want to do something there, but the second time, if there's nothing in the event graph, it won't open up. And we only care about the data at this point because, again, all of this is, the code is in the code behind. We just want to configure the vehicle using the data. All right, so as you can see here, this is an engine. Not too much has changed here since, compared to the prototype that I wrote and demonstrated and made a video series on. We have torque curve, curve scale, max torque, max RPM, idle RPM, engine braking efficiency, and then we have an up rate and a down rate. We're not going to do anything with the up rate, down rate, and then this is system health. And again, this can be controlled during gameplay, and also replicated over the network during gameplay. If you wanted to shoot out an engine and suddenly the vehicle doesn't work anymore, you could do that. But right now, we're going to go ahead and set up a Jeep engine profile. So for this series, for this tutorial, I actually wanted to use, since we're using a Jeep Wrangler, I wanted to go and get the real world data on a Jeep Wrangler, real world specs, so that we can kind of emulate that and see how my plugin kind of held up to that. So let's go. So to do that, and I'll leave a link to this below, but to do that, in setting up an engine, you can go out online and you can actually find, I kind of put in power curve for a Jeep Wrangler, and there's a bunch of things that came up, but this is kind of what you're looking for. We don't really care about this power curve, we care more about the torque curve here. Right. And that's this kind of, and so we're going to go and create a curve based on that, and as you can see here, its max torque is actually 230 pounds per square inch, or pounds per square foot. Right. So what we want to do is we want to change the torque from pounds per square foot to newtons, because that's kind of how we're setting up here. And also we're going to go ahead and mimic this curve, because this is the power curve. And so what we'll do, and so the way this works, and I already have an engine set up here. So for 4 liter, when I converted from pounds to newtons, I got 1023 for newtons. So that's the max torque coming off the engine, right? As far as the max RPMs, based on the curve, we were looking at about 5,000 RPMs, and its engine idle is actually 1,200, so we'll keep that there. Engine brake efficiency is okay, but there's really not much data on this, so we'll just keep that. So the only thing we need to do now is I'm going to create a curve, and so the way I'm going to plot the curve is going to be single digits. But I'm then going to multiply it by 1,000 to get the RPM. It just makes the curve a lot easier to work with. So let's go ahead and create ourselves a torque curve for our Jeep. All right, so to do that, let's come to the content drawer, and in mechanical, I'm just going to right click, and we are going to go to miscellaneous and various curves. And we have a series of curves. The curve that we want now is the curve float. So that's the one we want. So I'm going to select that. I'm going to say FC. And this is a 4x4 torque. All right, so this should give us an empty asset for our torque curve. So right now we're set at, as you can see here, it's just an empty graph. So first off, we're going to need a key. So I'm going to add a key, and I'm going to make this the max torque. So on the x-axis, this is going to be our RPM scale, and I'm going to keep this in single digits. So, and then we'll use the multiplier to get us to the actual torque. So this is going to be set to 3. So 3,000 RPMs, and at 3,000 RPMs, the efficiency of this curve is actually going to be 1. So this curve is not going to be giving us torque. Instead, it's going to give us the efficiency of the torque. And that way we can change the curves and not have to worry about, but we can, it gives us a bit more flexibility with the curve, I think, by using efficiency versus trying to figure out what the actual torque value, mapping the actual torque values within the curve. So everything's going to be based off that 100% at 3000 RPMs. So let's work our way back to engine idle. Right, an engine idle. So if I work my way back at 2000, and if I, let's see if we can bring this curve back up. So as you can see here, so this is 100%. So we're going to work our way back down the curve first a little bit. So as you can see here, we're going to be, the torque is going to come down at lower RPMs and drop off here at 1200 or 1200. So we're going to kind of mimic that, and then we'll come back and then we'll try and mimic the power drop off as we go into higher RPMs before it drops off at about 5000 right there. All right, so let's go ahead and do that. So the next key I'm going to put in is going to be at 2500, so it's going to be right here. So this is at 2.5 or 2500, and I'm going to say that that efficiency is actually going to now be 0.975. So as you can see there, it's dropping off a little bit. When we open this up, we'll rescale it, but for now, you can kind of see that it's kind of dropping off a little bit at 0.975. Then we get to another one we have another data point, so I'm going to add a key there, and this is going to be at 0.23, or at 2.3. And this is going to be 0.94. So as you can see, it's just little bits of percentages, but that's gonna get us up to 100. And then from there, we're gonna then see another drop at 2000. And that drop is going to be set to 9.3. Again, subtle drop. And then when we get to 1500, is going to be 0.92. Again, a little drop. And then from there, we are going to go to, I'm just going to go add the key at 1, but I'm going to move this up to 1.2, which is engine idle. And our engine idle is actually going to be 0.86. All right, so that torque curve looks kind of, doesn't look as dramatic. So what I'm going to do is I'm actually going to go ahead and close this and just reopen it. And there, it's a little bit more dramatic. We're only talking small percentages, but those small percentages in the curve, that's the curve tracing up to peak to peak performance. So now let's go ahead and add the curve coming back down after we get through the max RPMs at 3000. So the next one is going to be 3500. So I'm going to add a key there. And that value is going to be 0.98. And then I'm going to do another key at 4000. And that value is going to be 0.975. Okay, that stays there. And then I'll do another one at 4.6. And this one is going to also be at this. So as you can see, it's going to curve, it's going to flat as it's coming up to max RPM. And then when we get down to 5, which is going to be our maximum RPM, I'm going to add that key. And this is where I'm going to put a significant power drop off. So I'm going to take this to 0.72. So if I pull this back, so that's our engine torque curve. I think it kind of looks like that engine torque curve there. So that's what we're going to be mimicking. So let's go ahead and put this engine torque curve into our Jeep engine. So here's our Jeep. Oh, I should rename this Jeep engine. So let's find the curve, FC. There it is, there's the torque curve. I'm just going to compile this. I'm just going to close that real quick and let's rename this engine. All right, so if we open this up, so again, so we'll take those values, multiply it by 1,000 for the RPMs, and so when we get the RPMs, we're actually going to get the percentage of the efficiency, and then we'll multiply the efficiency. Well, I'm multiplying the efficiency by the max torque, so that will then get me the percentage of power that's going to be put onto those wheels. All right, so that is the engine. So let's go back to our Jeep. Let's close the torque curve. And let's just drop this engine into the engine slot. All right, so now we've got an engine. Now all we need is a transmission. So I'm just going to close the engine. And we're going to content drawer. And under mechanical, I'm just going to right click and we'll go to blueprints. Under all classes, Seren, just like everything else. Type Seren and physics transmission. Give it a name. So here's our transmission, and we're just going to open this up. And then I'm just going to go close it again, since all I want is the data, and we'll just open it up again. So this is our data, this is our transmission setup. So I'm going to keep this as an automatic. I don't care for auto reverse. So again, this is an option if you want something which is very arcade-like, where you don't want to have to switch into reverse. You just want the thing, if you hit the brake and it stops, then it'll start reversing. You know, if that's what you're looking for. If you want something a little bit more realistic, you just take that off. Auto drive, as soon as I hit the gas, it'll put me into first gear. And then auto brake, again, is a setting that if the vehicle has stopped and has 0 velocity, it'll turn the braking system on to prevent the car from rolling downhill. Okay, so final drive ratio. This is actually very important. This is the reason why I wanted to do the wheels first. Because the wheel size is what's going to determine the final drive ratio. So this is actually the differential gear. So when you've got the engine provides power through the transmission to the shaft that then gets connected to the wheels through the differential gear. And that differential gear is usually determined by the size of the tires that it is going to be turning. So to do that, I've got another little aid to kind of figure that out for us. So just give me a second. I'll pull that up, and I'll show you how you can kind of figure out what your final drive ratio should be if you kind of want to start using real world data. All right. So again, you can look this up online. Just put in gear ratio. So if you type gear ratio, it's going to assume that you're looking for the you're not looking for transmission gear. This is the differential gear. And again, so this is based on the tire size. So what you're going to do is you're going to figure out so again, this is in imperial or English, right? If you want to convert to metric, just take the metric, do the conversions from centimeters to inches. And when you do that for a 48 centimeter tire, it should land either at 37 or 38 inches, so it's a pretty big tire. So what you're going to do is you're going to come over here. So anything in yellow, this is kind of like the this is economy. So if you want to mimic a vehicle that is a gas sipper, then these are the gear ratios for the tire size for an economy vehicle. If you want something which is more balanced, so it can do both economy and but have some get up and go, you're going to use the green. And if you just don't care about the environment and you just want to go hog wild, then you'll use the blue, where you'll just drain your gas tank and get the most power out of your vehicle. So again, that's what the blue is. So I'm going to go with the green. And again, we netted around 37, 38. So the optimal gear ratio would be, you could either use 4.88 for our tire, or you could use anywhere between 4.88 and 5.29. That's the band here. That's the optimal gear in the green band. For the tire size. So that's kind of where we're at. So I'm going to use 4.88, but if you want to use something a little higher, you can. So I'm just going to take that off, and I'll include the links to these sites so that if you want to kind of check it up and reproduce it. So that's what's going to go into here, final drive ratio. So that is going to be 4.88. All right, and I'm going to be using a 8-speed. I'm going to use an 8-speed transmission, an automatic 8-speed transmission for this. But yeah, there are 6 speeds and 5-speed automatics or 6-speed manual. It's up to you on how you want to do it. But I wanted to use 8 gears to kind of put in a lot more gear ratios. So again, it's up to you on how you want to do it. So, and again, you can find this information when you're looking for this. Type in transmission gear ratio. Otherwise, if you just put gear ratio, it'll assume, Google assumes you're looking for this. But if you put transmission in, now I don't have any fancy charts. It's a little bit hard to find this data. Sometimes it's just in text format, but it will come out. So I'm going to have 7 or 8 gears going in the forward and 1 in the reverse. Actually, let's just delete that. So let me go find my other transmission to get those numbers. All right, so I'll start with the reverse gear. So for me, I'm using a reverse gear of 3.3. For first gear is going to be 4.71. For second gear is going to be 3.13. Third gear, okay, I'm going to do a 2.1, 1.67 for fourth gear, yep. Okay, fifth gear is going to be 1.28, and then sixth gear is a 1-to-1 ratio. So this is the 1-to-1 ratio. So when we're in sixth gear, will be on the final, using a 1-to-1 on the final drive ratio. And we have 2 overdrives. So overdrive 1, which is at gear 7, and overdrive 2 is gear 8. So anything less than 1 is an overdrive gear. So these are for cruising, and this is for muscling up to into our optimal gear. All right, as far as, so if we're using an automatic, we need to have a RPM upshift and a downshift. So I'm actually going to set my upshift at 4,000 RPM, so it can be a bit more aggressive. And I'm going to set my downshift. Actually, I'm going to keep it at 2,500. No, 2,000. I'm going to move it to 2,000 RPM. So if we go less than 2,000, the engine RPM, the engine will downshift. If our revolutions on the engine go above 4,000, it will upshift into the next gear. As far as gear shift timings, I'm sure you could probably find that. I'm just using this 0.2, and transmission efficiency is 0.9, so it's 90% efficient. As far as differential type, so this is how we, so this is important if you're using, this is the reason why we, in the Jeep setting, we want to make sure our drive axle type is front or rear. So if you do this and you find your vehicles are not turning, check to make sure that your axle setup is set to either front axle or rear axle, right? Because that's what this is going to do. So if you're using a all-wheel drive, then you can actually decide, you can actually split how much power do you want on the front versus the rear. So if you want a 50-50 where both tires are equal, just do 0.5. If you want more power on the front wheels, get it closer to 1. More power on the rear wheels, get it closer to 0. I'm just going to set this to 0.5 for this tutorial. And again, if you wanted to have a rear wheel Jeep, just set it to back wheels. A front wheel Jeep, set it to front wheels. And then, all wheels means all 4 wheels will be going. And again, as you and you will notice the difference in how the vehicle drives when you actually do move that variable. All right, so now we set up the transmission. So let's go back to our Jeep and go back to mechanical, and we can go ahead and see there's the Jeep transmission and drop that right in there. Okay, so now we've set this up, we've got cameras, so let's go ahead and set this blueprint up so we can actually move this vehicle forward. All right, so to do that, we're going to need input mapping controls. So let's go to the content drawer. If you don't have one already, under content, create a folder called input, and then create a subfolder called input actions. And under here, we're going to go ahead and create ourselves several actions that we're going to need to move this vehicle. So let's go ahead and create one for input action. So I'm going to create one for throttle, and I'm going to open this up, and I'm going to set this to 1D. So this is going to be axis 1D because this is going to be using an analog. And then I'm going to go back into the drawer, and let's just duplicate this, and this is going to be we call it brakes. And then I'm going to create another input action for steering. And again, I'm just going to make sure that this is set to 1D. So this is all of our analog setups. So that's throttle. Brakes should be analog as well. Yep, good. So I'm just going to go ahead and save everything real quick. Let's just close the transmission. All right, so that's the brakes. So the only other things I'm going to go ahead and add the cameras in there so we can tie that onto the game controller. I'm going to be doing this through a game controller. So where is my input? There it is. So for that, it's going to be more like push buttons. So I'm going to say IA underscore camera pause, and make sure that's a digital. And I'm also going to duplicate this camera select. So this is going to be position, this is going to be camera. So this is going to be going from side profile to front, and this is going to be the camera position for the first person, between first person and third person. So we'll do that. So I'm just going to save everything. All right, and then finally, if you wanted to, you could put a parking brake in there if you wanted to. I'm not going to do that for this tutorial. So those are the things that I've got. I'm going to come back into inputs. Let's go ahead and create an input mapping context. So go to input, go to input mapping context. Going to call it IMC. wheel vehicle, and let's pop this puppy open. Alright, so within here, we want to come under default key mappings, and this is where we're going to go ahead and add our mappings. I'm just going to close everything else since I don't need it. So first off, let's go ahead and get our throttle. So there's our throttle. And let me go take a look at how I'm setting this up. So under throttle, so the easiest way to do this, when it's to power up your controller, I can click on the keyboard there. That once it turns yellow, I can set it to the throttle to the control that I want, and it'll automatically map. So it sensed that I hit the right trigger, so my right trigger is my accelerator. And since this is an analog, we're going to need to add a modifier and add some dead zone in there. So there's the lower threshold, there's the upper threshold, smooth radical, radial. So we're just going to keep all the default settings there. So that's good. Going to add another one for brakes. So for brakes, I'm just going to do the same thing. Hit the plus. No, don't want to do it. Wrong one. So under brakes, I'm just going to hit that, and that's going to be on the left trigger. So my brakes are on the left trigger, my accelerator is on the right trigger. And again, because it's an analog, we're going to need some dead zone. And then finally, I'm going to add another mapping for steering. As you can see, I've got a lot of other mappings in here, but I'm only going to use this one. And for steering, I'm going to use the right control, thumb control. And that is going to set up our steering. And again, since it's an analog, let's go ahead and set up the dead zone for that as well. And then we've got two cameras, so let's go find that real quick. So we have camera position, so this is going to be side versus left versus right. Or this is going to be back versus side profile. So to switch the camera, I'm going to go ahead and put that on, say, I'm going to run it off the gamepad D left. So if I hit that, that'll go. And since that is a press, I'm going to switch this so that it does a pressed. So this is a trigger modifier, so this will modify the trigger output to being pressed. So if I press it, it'll fire the trigger once and it won't fire it repeatedly. And then I'm going to do another one for camera. Actually, we already have camera pause right. Let's see, I've got throttle, brakes, steering. Camera pause. We want camera select. So, and again, I'm going to just click on this and I'm going to use the gamepad right to determine whether we're going to be in first person or third person mode. And again, I'm going to use a trigger modifier and do a pressed on there. All right, so that should be our package. So now let's come back to the Jeep and let's go ahead and start setting up our controls. So first off, I'm going to take the debug keys and let's fix those. So IA_cam. I'm just going to get, so this is camera possession, and I'm also going to get IA_camera selected. So here, I'm just going to go ahead and hook that trigger in there, and that's all we need to do. and I'm just going to hit that trigger into the flip-flop, and we can now get rid of the debug keys. And so we can now run that off the controller. And I'm just going to go ahead and move all the camera stuff down here. If you wanted to, we could also go ahead and put a comment. This is our call it cam settings. So it's our camera stuff. That's under a comment zone. Makes it a little bit easier for us to move it. So I'm just going to put that up there, keep it out of the way for now, so that we can focus on setting up the vehicle setup or vehicle control inputs. Oh, that's right. Yeah, we'll get back to that. All right, so first off, let's go ahead and set up the throttle. So I_throttle. So as you can see, this is an analog, trigger analog, and I'm also going to get out the IA_brakes. And IA_steering. All right, so for all of this, we can actually run this through. This is all going to be run through the movement component again. So let's grab the movement component, and under movement component, we have a function called set throttle input under vehicle movement. And this is where we can actually do input throttle in context mapping. So I'm just going to go drag this in. So that's the value coming in. I'm going to assign this to throttle group 1. So this is where it gets important on how, in this component on setting up your throttle groups. So under engine, I have control throttle group 1. Let's come down to input. And under here, we have throttle input, and we have a default group already set up for us called throttle group 1. And so what we're going to do is we're going to set up the rise and the fall. I want to tame the throttle a little bit. So I'm going to set this up to a 0.5 on the rise rate and a fall rate of 5. So if it's increasing, we want to slow it down. That way I don't have my back wheels spinning out of control if I just slam my finger on the accelerator. So that should be mapped in. So it's a map to a map to a map. All right, and the component will handle that. And I'm going to use engine simulation instead of thrust simulation. And it's just, this just allows me to figure out how I want to clamp the value and where to assign it when it gets passed through the physics network physics component from the game thread to the physics thread. All right, so for brakes, same idea. We're just going to go grab this guy, Seren, and we'll say set brakes. And as you can see, we've got a lot of different braking options here. We want the wheel brake input, and this is going to be wheel brake for analog. So that will set our wheel brakes. You also have an option for handbrake. So this is kind of like the old style handbrakes, where it's that ratchet handbrake, where you can set how much of the handbrake you want on or off on your vehicle. I also have one for parking brake, and that gets done through a different function. Since it's more of a Boolean, it's either on or off. And then we have steering. So let's go and find our steering. So set wheel steering. And again, we just connect the dots. Just clean this up a little bit. So the one thing I forgot to do was add input context for gearing up and gearing down if you wanted to use a manual if you wanted to set the system to manual transmission. So let's go ahead and add those real quick. So I'm going to go to input actions. Let's say IA underscore gear up, and then I'm then going to duplicate that for gear down. And again, these are just simple booleans. So now if we come back to our mapping context, I'm just going to go close this, and we'll add another one and close this again, and we have gear up. And I'm just going to go ahead and add gear down while it's still doing this weird stuff. Save it. All right, so we have gear up and gear down, and I'm going to assign these to my bumper buttons on my controller. So if I want to gear up, I'm just going to go on the right shoulder. If I want to gear down, I'm going to use the left shoulder. And as far as the trigger, I'm going to put a trigger modifier on here of pressed. So all we have to do is just press. And once we press it, that will push up the gear. So if we want to use manual overrides or paddle shift, we're going to use a paddle shifter to paddle it up and paddle it down. All right, so now we can come back to, so that's gear down, gear up. So now we can come back to the Jeeps and we can go ahead and set that up as well. Gear up, and I might as well get gear down. All right, and then we should have a set gear shift function. Going to just copy this. So the way that this works, the gear shift function, it just takes a boolean depending on how you want to shift. So if I'm shifting up, I'm going to set it to true. If we're shifting down, we're going to set it to false, and it will take care of the rest under the hood and how it interprets that. So that's all we need to do there. So gear up, gear down, mapping contexts are all good. So now we need to enable that context within this pawn class. So let's go ahead and do that real quick. All right, so to do that, I'm gonna be binding this to the receive controller change. So let's go ahead and find that. There it is. There's the receive controller change. This is a good one, especially if you're building games in which you may want to possess vehicles. So if you're moving from like a Grand Theft Auto type where you're going to go steal someone's vehicle, this will set the controller package as soon as the controller comes in and you do that pawn possession. This thing gets fired. So off here, we're going to go and cast to the new controller. And this one's just going to be to the player controller. So if this gets cast to the player controller, then we can go ahead and we can look for the enhanced input. And there it is right there. That's the subsystem that we want. And one thing I found when working with multiplayer, we want to do an is valid. If you're doing standalone, you can get away with not doing this, but on multiplayer, you just need to do an is valid because there seems to be some additional things that it does under the hood. or a different site as it does the pawn possession, so which could cause an error. And then off here, we're going to say add mapping context. And we're just going to go ahead and find ours. All right, so as long as we're using the right context, that should be the bare minimum we need to get this vehicle moving. So let's go ahead and test it out and see if we can get this vehicle to move for us. So I'm just going to compile everything, save it, and let's just move this off real quick. All right, so everything's moved off. There's our vehicle. Just double check to make sure player possess pawn, player 0, so it's on our main controller. So let's go ahead and see if we've hooked everything up. So I'm going to go ahead and hit play. Vehicle's going to bounce onto the ground. I'm going to click on it, and there we go. There's our vehicle. Switch the camera mode. Why are we not? Oh, I think. Yeah, let's make sure we've got that in the right. Let's make. It looks like we got a little bit of a bug there for our first-person camera, so let's go debug that real quick. Where's our cameras? Camera select, camera position. Let's go to our context. Camera mapping context is up here. So, that's because we don't have a camera. Oh, that's because we put it onto here. So, I'm just gonna take that off there and put that on here. All right, that should fix that. So let's hit save. Let's do this real quick. So and there's our vehicle driving in first person. And there's third person. All right. So then the only other thing we can do, we can go ahead and do is create a nice little spiffy UI. So we can kind of see what the values of the vehicle are coming out. But yeah, that's pretty much it. We've got a vehicle that's under our physics movement driving around. All right, so I'm just going to go ahead and stop this, and we can move on and go ahead and create that little HUD so we can kind of figure out how fast we're actually going with our vehicle. So I'm just going to do that. All right, so let's come back to our content drawer. I'm going to go into blueprints. And under content blueprints, I'm going to create a new folder called UI. And within there, let's go ahead and create a new blueprint. But we're going to use a user interface widget blueprint. So come down, user interface blueprint widgets. I'm going to hit the user widget. I'm going to go WB 4x4 Jeep HUD, and from there we're going to open this up and let's get started. So I'm going to go ahead and create a canvas panel first, since this is a HUD, and we're just going to drag that into there, and then off that, we're going to get a vertical box. And then within the vertical box, let's go ahead. I'm going to set the anchors. So I'm going to go left shift to move the anchor down. And then I'm going to hit the anchors again. And I'm going to go left control to move the box down. And then from the position, I'm going to go 40 into the screen. And I'm also going to then go negative 40 above. So we'll start there. So that kind of gets us into the corner. And then from the vertical box, let's get a horizontal box. And we'll drop that into the vertical box. And while I'm here, I'm also going to get a size box as well. So let's just get a size box, and I'm going to put that underneath the vertical box. So the size box is where I'm going to be putting the RPMs coming off the engine. So I'm just going to go set that layout since it's a little bit easier. So I'm going to set a padding on that box of 16. Set to autofill. I'm not going to go and override anything on that size box. In there, I'm going to put another vertical box. And within there, I'm going to put a text box. And that one I'm going to set to txt RPM and make it a variable. And then underneath it, let's just add another text box instead of vertical, and I'm gonna set this, keep this as just text, and this is gonna be engine RPMs. So as you can see here right now, everything's kind of bleeding out. So we'll fix this once we've got all of the layout in there. So engine RPMs. Let's see. Let's give this a. Let's change the text on the engine RPMs. I'm going to go into font. It could say 32. I'm going to go light, so it's going to look a little skinnier. And we'll keep, since I only have Roboto, we'll just keep the Roboto in there for font. And I'm just going to make sure it's centered and centered. Actually, no, I want it to fill and fill, and I want to make sure it's center justified in the box. And I'm going to go ahead and get the RPM text. I'm going to keep this at 32, but it's going to be 32 bold. I'm going to center align that too. All right, so that's in the box. Hit compile, save. So I'm going to come back up to our vertical box. And let's see what we've got here. Performance, transforms, pivots. It's going to make this vertical box a bit bigger. So I'm going to set the size there. Just trying to see where the vertical box is. Okay, there's the size. So, we'll start with that, and then we'll just adjust as time goes on. As far as alignment, we can keep that. Actually, I'll probably just click to say size to content, so I'm going to be putting all the content in there. And the content's going to be kind of fixed anyway, so I think that that'll be okay. All right, we'll play with it. All right, so that's the RPM. So now let's come back up to the horizontal box, and we'll go in the horizontal box. I'm going to put another size box in there. So let's go get the size box. And again, I'm going to put a padding of 16 on the size box, and we'll keep it auto. And I'm actually going to set the width of the size box to 200. All right, I'm going to hit save. And I'm not going to set the overall height because the height will be based on the content that's in it. So in there, again, we're going to put another vertical box. And within there, we're going to put 2 more text boxes. So the second text box, this is going to be our unit label. So this is going, and it's just going to be, I'm just going to keep this static text, and I'm going to just run this as RPMs. If you want to change it so that you can set up the unit labels dynamically, you can do that. I'm just going to keep it simple for now. So here, autofill, I'm going to justify that to the middle, and I'm going to set this to miles per hour. And again, I'm going to set this to light to make it show there's a contrast there. Hit save. Keep it at 32. And then the other one, this is actually going to be a variable, and this is going to be the speed. So I'm going to call this txt speed. And again, I'm going to center align it and just keep everything else the same. As far as the font size, I'm going to take that up to 96. And I'm going to just put a 3-digit number in there. That should be the largest number that we can put into there. So this is going to be I'm using miles an hour. You can switch. I'll show you what you can do to switch between miles an hour and kilometers. It's really just adding an extra step when going from kilometers, because we'll calculate in kilometers first, and then I'll switch to miles. And then we're going to need to do something similar for our gear. So again, just going to go ahead and get another vertical in the horizontal box outside of the size box. We're going to add another vertical box. And in that vertical box, I'm going to switch. I'm going to make that, so vertical alignment is going to be on the bottom. We'll keep the horizontal in the middle. Set to auto. As far as behavior, that can stay the same. Everything else can stay the same. So, all right, so we now have our vertical box here. And then within there, we're just going to have 2 more text boxes. All right, so text 1 goes in there, and text 2 goes in there. So this is going to be a simple label, so we'll just keep this regular and say gear. So this will be the gear indicator. I'm going to just center align that under justification. And as far as this is going to go, we're going to set this from bold to light, and we'll keep it at 32. And then as far as this box, again, we'll center align it, which is, this is now the gear, the actual gear label. Going to center align it. We'll bump this up to use 64, keep it bold, and there's just going to be a single gear indicator there. And I think what I'm going to do is on the vertical box, let's add, I should be able to add some padding. Yep, I'm going to add 16. All right, so that kind of pushes that out. All right, so there's our widget that we're going to be using for our HUD. So we'll have, I'm going to be using, again, I'm using miles per hour. I'm just used to that. So we'll be, go ahead, take the data in and calculate that. So, all right, so now we've got the layout done. Let's go ahead and go to the graph. All right, so before we do that, let's go back. I need to go back to the designer real quick. So we have our gear here. I need to turn that on and say txt gear. So, all right, so this is now a variable, so we should see this in the back. So if we come back to our designer graph, we have 3 variables. We have speed, RPM, and gear. And I'm going to do this through functions, so we can pipe this in from the vehicle into the HUD. So let's do a function called up. This one's going to be update speed. And update speed, and it's just going to take an input, and this input is going to be a float, and this is going to be speed. So pretty self-explanatory there. This is going to be a public access function, so we're going to populate this actually from the blueprint, from the vehicle blueprint. So update speed. So to do that, we're going to go grab our txt, and what we want is to say set the text, and we're going to use that function there. So our goal is to get the speed out of here and format it and put it into here. So the speed is actually being calculated in centimeters per second. So, and we want, and speed is usually going to be absolute. So since we're in centimeters per second, I'm going to convert it from centimeters first. I'm going to convert it from centimeters per second to kilometers an hour. So to do that, we're just going to multiply. So we'll find the multiply operator. And so for the conversion ratio from that is 0.036. So that will convert centimeters per second to kilometers an hour. So if all you want to do, if you want to stay metric and use kilometers an hour, then that's all you need to do, and then you can just pipe that value into the text box through a toText and float. And we want to use this toText float because we're actually going to set so that we can do some formatting. So for this, we're just gonna we would just format it here. I'm just gonna say half to even for rounding. Maximum integer is going to be 3 digits. We shouldn't be getting over more than 3. We have no minimum fractal and no maximum fractal, so we only want whole numbers. So again, if you want kilometers an hour, you can stop there. If you want to go to miles per hour, then we just have to then just do another, we just then take this and divide. And we're dividing this by 1.609. So that's the conversion. So that will convert kilometers an hour to miles per hour, if you're looking for that. And then we just need to make sure we hook that up. And there we are. All right, so that should do it for speed. So next I'm going to go to RPMs. So I'm going to add another function. And so this is our engine RPMs. So again, I'm going to click on this. I'm going to say we're going to take an input, and this will be current RPMs. And with this, again, I'm going to keep it I'm going to use we want the absolute. And again, I'm going to do a toText. A toText float. And again, we are going to go ahead and set that to 0. We only want whole numbers. So this will give us everything up to whole numbers. And we can keep everything else the same. 1 and 223. So this can go up really high. And then I'm going to get this guy and say set text. Hook that to there and hook that to there. And that should do it for the engine revs. All right, so then lastly, we're going to do a function for our gears. And this is going to be a little different. So first off, we're going to need an input. But this one is not going to be a float. This can be an integer because gears are whole numbers. New gear. So this is the gear that our transmission is going to be set to. And on here, I'm going to run this through a switch on int. And for this, we're going to have a default. I should be able to set this to -1 because I need a start index. So to do this, I'm going to set start index to -1. And the reason why I want -1 is because if it's -1, it's going to be reverse gear, right? If it's 0, it's going to be neutral, and then everything else is going to be a positive gear coming out of this number. So that's how we're going to set that. So coming up here, if we go ahead and grab our gear text, get this and say set text. So here, since we only have one reverse gear, we can just put it in R. That's for reverse. And if it's 0 coming through, i.e. the integer is set to 0, it's going to be in neutral. So we're in neutral gear. And then by default, any other number coming through is going to be a positive gear. So I'm going to grab this, and from here we are going to say to and we're going to just use the integer. And off here, we're going to say 1 and 1. And that's going to go into there, and that will be the default. So this is pretty much unless we are either -1 or 0, right, any other will actually use the gear number coming in off the new gear. And we can keep all of those settings as is. All right, so hit Control, save, compile. So that's everything we need to do there. We don't need to do anything else. So let's go ahead and go back to the vehicle, to our Jeep, and go ahead and tie this in. I'm just going to go grab our camera stuff since I can now put that there. Let's go ahead. I'm just going to go put a comment on this and just call this inputs. So there's all of our inputs. I'm just going to move this down a little bit, and this is our camera inputs. I don't need this begin overlap, but we do want event tick. And we're also going to need begin play. So on begin play, this is where we're going to go ahead and set up our HUD. So what I'm going to do, what I like to do again, if I'm creating a vehicle which could be possessed, let's do a cast to player controller. And I'm going to say get player controller. So what this is going to do is it's going to check to see. Actually, we don't want this one. We want get controller. Oops. Get controller. So what we're going to do is we're going to test to see if the controller that is controlling this vehicle is a player controller, right? And so if it is, then the player has possessed the vehicle, and if the player has possessed the vehicle on begin play, or has possession of the vehicle on begin play, we'll go ahead and create our HUD. So, and we can do that through this create widget node, and from here WB, there's our Jeep HUD. That's what we want. And if that is successful, I'm going to say promote to variable. Let's call this Jeep HUD. And we can say add to viewport. All right, so we'll create it and add it to the viewport. So that gets us the HUD, but now we need to populate it with data. So what we're going to then do is we're just going to come and get our HUD, get Jeep. Let's make sure it's valid. Is valid. So, and we will hook that into there. So once this has been made valid on tick, right, then we can go ahead and start populating this information. So I'm just going to go ahead and say copy, paste, and what we want is so we have update speed, update gears. And finally, update the RPMs so we can see the engine time, the engine RPMs. All right, so all of this information is actually ready for us to be used because it's being calculated within the movement component itself. So to do that, I'm just going to drag off here, and there's two places we need to go to get this information. So there's the get. So there's the get current vehicle state. So this was where we'll go to get the current speed of the vehicle, but we also have the get current simulation outputs. So these are the two. So the simulation's running, and as the simulation's running, it's doing two things. It's going to always update the most current state of the vehicle, and this is being done on the game thread. And this is the current state of all the simulation data that we're using to produce all of the forces. So this is what we can now use to, again, drive the animation. This is what's used to drive, the output is what's used to drive the animations or the UI. So I'm just going to give us a bit more space. Oops. So let's give us plenty of space there. To work with. All right, so for speed, we're going to come off the get current vehicle state, so we can just drag off there and say, and do a break. And as you can see here, this is the state object. So not much has changed here since the video series. We got true mass, if you're interested in that, but then we have world velocity, world angular velocity. So this is up, down, left, right. This is how much it's spinning. So for forward speed, we're going to want this information here. So I'm going to grab this, and I'm going to say break that. And all we need to do is just take the speed and park it in there. And then to tidy it up, I can just say hide. And to tidy it up, we can just say hide. Easy. So that's the speed, and that's just coming off there. So to get the gears and the RPMs, that's what this guy's for. So I'm going to say break. And if I open this up, there's a lot of data that we are updating and outputting. So this is and again, this is being calculated on so the state is on the game thread. This is based on what the vehicle is doing after the forces have been enacted on the vehicle. This is the simulation outputs. This is coming over back to us from the game thread, from the physics thread. So this is all the data. This is the most current data so for every tick, this is being updated, and you'll have this, all this data in this structure will be updated and output. So for the wheels in the animation, that's what we're running off here, right? So all I've done and that's what the animation blueprint has done, is we just created a nice way to keep that clean. But you've also got control surface angles as well. I've added that for flight control surfaces. Works the same way. So, and then we also have local dampening. So if you wanted to see what the world, how air or water is pushing back on your vehicle, you could find that information. But right now, all we want to do is we just want to get the gear and the engine RPM. So gear is coming from current gear. So we're going to put current gear into current gear, but we also have the target gear as well. And then engine RPMs that's what we want for that. But again, we've got a lot of other data coming off here. You could, if you needed engine torque or transmission RPMs, you could pull that information as well as transmission torque. You've got the transmission type, so this is the current transmission type if you want to change transmission. Immersion state, this is for vehicles that float or sink. as well as any custom state, and again, and then whatever the throttle group is set to. This is the information you want to use, because this is going to tell you what the simulation is set to, versus trying to calculate it off the raw. So this is a lot more accurate, as well as foil geometry. This is the wing, if we want to change the shape of the wing and what that's set to. So again, this is all designed so you can run animation and UI. So that's what's currently in the outputs. So just to clean that up, because there's a lot of information in there, I'm just going to go ahead and put that in. Set that there, connect, and connect. So if we've done everything right, we should have our HUD show up in our vehicle, and we should then be able to see what the actual speed, gear, and the engine RPMs are for our vehicle. So let's go ahead and take a look at that. So I'm just going to move this again off screen, and we'll go ahead and set that up. Alright, so now we're back to our vehicle. Let's go ahead and fire it up, and we should see a HUD with the data of the vehicle. So I'm just going to hit that. I'm going to just click on there, and if we fire it up, our vehicle is moving, and as you can see, it's running and rolling around on the desert floor. I can change the angle. Great. Gearing up through the gears. You can see it's trying to find the optimal gear. It kind of goes all the way up to the top and then comes down the stack. And I can switch to inside the vehicle. So it looks pretty good. Going to come up over to the hills. Going to come to the outside. And just let our vehicle just roll around. Nice thing about an automatic gearbox, it'll automatically downshift, and the braking works, and everything else works as we kind of go over the hills. All right, so that should do it. So that's how you can set up a wheeled vehicle with using my Seren plugin. Again, as I said, no C++ needed. And yeah, and as you can see, you're getting with the update that I made to the wheels, looks like we've got some pretty good performance for our vehicle as it's kind of moving across the desert, moving across the ground. And this is all, again, using physics movement. So, all right. So that's going to do it. As always, if you like what I do, feel free to like and share my videos. You can go ahead and leave a comment below. I always enjoy reading them. And yeah, I'll see you on the next video. Cheers, and have a good day.